solving a nonlinear system. It's exactly what it sounds like. It's a system of equations where at least one of the equations is nonlinear. So, a system of equations in which at least one equation is not linear is a nonlinear system. So substitution is going to be your go-to in this case. So we have x squared minus y equals 4, and x plus y equals negative 2. We can't, I know it looks like, hey, let's use elimination, but x squared plus x is x squared plus x. We don't want to do that. So, don't want to doesn't mean you can't. Okay, let's do it that way and then use substitution. You convinced me. You convinced me. Let's see what happens. So x squared plus x is just x squared plus x, nothing more we can do. Equals 4 minus 2 is 2. X squared plus x equals 2. Get everything on one side. 0 on the other. Factor and solve. So again, I use elimination. I'm completely doing the opposite of what they say to do in example 1, but I still will come back, do substitution, show that it works, and show that it might even be better. It's not always going to be given to you like this. Numbers that multiply to negative 2 and add to positive 1. X squared, so x and x. This is going to be plus 2 minus 1, which gives us x equals negative 2 and x equals positive 1. We need to take both of these x's, plug them back into one of the equations, and solve for y. So, negative 2 plus y equals negative 2, but also 1 plus y equals negative 2. So y equals 0 when x equals negative 2. And when x equals 1, y equals negative 3. So negative 2, 0, and 1, negative 3. So that was using elimination. If you want to, again, just remember, this is not going to be 2x. X squared plus x, there's nothing you can do to that. It's just x squared plus x. Okay, now let's do it again the way they asked us to. We'll see we get the same answer. So if x plus y is negative 2, y is negative 2 minus x. So x squared minus y is x squared minus negative 2 minus x. X squared plus 2x, or sorry, plus 2 plus x equals 4 gives us x squared plus x minus 2 equals 0. And you know what you're going to do from there? All the rest of this. Factor, solve, plug in. So you will get the same answer, because there's the rest of the work. If you didn't write it down, go back and rewind. See how we did it from that point on.
y equals negative 2x squared plus 39. And x equals the square root of y. Neither of these are lines. That's why it's nonlinear. We're going to solve this using substitution. Now, one thing you can do is take this expression for y and plug it in here. The other thing you can do is take this expression for x and plug it in there, but you're going to get the same answer either way. So x is the square root of y. Let's plug that into the first one. Y equals negative 2. Instead of x squared, it would be the square root of y squared plus 39. And the square root of y is just y, so negative 2y plus 39. Add 2y to both sides, we get 3y equals 39. We get y equals 13. And x is the square root of y, which means x is the square root of 13. So our answer is the ordered pair, where x is the square root of 13 and y is 13. So that's systems of equations. A related concept is that of systems of inequalities. And I want to go over this briefly, quickly. The first thing we would have to know how to do is how to graph an inequality in the XY plane. So let's say we had 3x minus 2y is less than 6. Well, we'd pretend that we have 3x minus 2y is equal to 6, and we would graph that first. If it was greater than or equal to, less than or equal to, if the or equal to was there, we would use a solid line. But here in the case where there is no equal to, it's just less than, we're going to use a dashed line. So 3x minus 2y equals 6. We can find our x and y intercepts. When x is 0, y is negative 3. When y is 0, x is positive 2. X is 2. Y is negative 3. There's our dashed line. Now, to account for less than, we need to do a test, just like we did with our other inequalities. Here, the test is going to be, does this point satisfy the equation, or does it not? Or satisfy the inequality? So I'm going to pick this point right here, 0, 0, clearly on this side of the dashed line. I'm going to plug 0, 0 in. Is it true? 0 minus 0 less than 6, 0 less than 6, absolutely true. So 0, 0 is part of the side that works. So we shade that side of the line. X is less than or equal to negative 1. Well, just like we would do on a number line, there's negative 1 on the X. But instead of just shading this and doing a solid circle or a square bracket to indicate that -1 exists or that -1 works, we put our dashed line, which since the or equal to is there is not dashed, it's actually a solid line matching up with what would have been a filled in circle. And instead of just shading on the x-axis on the number line, when we're on the xy plane, we shade everything to the left, everywhere that x is less than or equal to -1. Likewise, what if we had y is greater than 3? Well, we find y equals 3. It's a dashed line because there's no or equal to, and everywhere where y is greater than 3 would get shaded. Okay. Now, what if we had the system of inequalities? (3x minus 2y is less than 6). X is less than or equal to -1. Y is greater than 3. We would solve this graphically. 3x minus 2y is less than 6. We saw was this inequality. The side with 0, 0 was included, so we shaded above. We graphed that one. Now let's graph this one. We saw where -1 was. It was a solid line. We shaded everything to the left. Notice some of it's overlapping. Y is greater than 3. We shaded everything above. Only the parts I've really made a mess of this, huh? There we go. Only the parts that overlap all three are the solution to the system of inequalities. So I made a mess of that by trying to do all three at once. But let's say we have a system of nonlinear inequalities. Y is less than or equal to negative x squared plus 4. X minus y is greater than or equal to negative 2. Y is greater than negative 5. This one is an upside down parabola moved up 4. The shading is on the inside. This one is a line shaded down here. And this one is shaded up through. Well, only the part above that line and inside the parabola would make it into the final answer. So it's almost like we have this weird shape here. The intersection of all three shaded regions. So that's what a system of inequalities is and how we would deal with that.